Well, hello, and thank you all for being here to, I believe, our 16th annual Math Busters game show. We have had a wonderful 2 weeks with your children, and we thank you for entrusting them to us. We have endeavored to provide a very engaging and fun environment where students are pushed to develop greater problem-solving skills and mathematical reasoning skills, and they will very proudly demonstrate some of that learning and those talents for you today, obviously in an environment that for many of us would be a little intimidating. So I know that they're glad to have family members here who they know love them unconditionally, right, and are supportive every day, and we thank you for that, because without that kind of support from you, our community, we would not be able to offer these kinds of very valuable programming. So thank you so much. A little bit later in the program, I'm going to be introducing some of our very, very important instructors and directors of the Academy, but we want to get on to the game show, which is what you are all anxiously awaiting, and not make our little contestants squirm in their seats. So with that, I would just like to mention two lovely people who are standing behind you, who you might have noticed are not fourth graders. On my left here is Anna Schufelt, and she is a recent graduate of Okemos High School and has been with us for a couple of years now and very experienced, and she has been a wonderful student assistant helping out all this week. And on my right, David McKinley, who is still an Okemos High School student, and this is his first year with us, and we hope he's going to keep coming back. And he has been coaching and helping with our other team of students here, and you can see they've picked some wonderful names, Fibonacci's Factory of Factor Fans. So I love that. Yep. Give them a hand. I really appreciate the fact that we've got math and we've got language arts going on with alliteration at the same time. Well-rounded kids. And, not to be outdone, we have the marvelous mathematicians here on my right, again with that alliteration and math skill as well. And now our own resident game show personality, who we are so fortunate to have. You've probably seen him on WKR hosting Quiz Busters, and he very graciously every year devotes some of his time to us, making this a real highlight, really, of our 2 weeks together. So without further ado, to get Math Busters started, please welcome warmly Mr. Matt Ottinger.
Thank you. Thank you very much. Welcome. First of all, how many of you might have older sons and daughters who've been through this rigmarole before? Anybody? A couple, well, just a couple of you. Good. So I can use the same jokes I used last year. That'll be good. No, we're going to have a lot of fun in the next hour. I, unfortunately, don't get to spend a lot of time with your students. We had a brief practice session yesterday. We were here very early this morning checking the buzzers and making sure everything was all right. So I haven't had the chance to spend time with these terrific kids. But I've heard wonderful things about them, and certainly the brief time that we've had together has been fun. We're going to play a game. That's all we're going to do. If you're familiar with Quiz Busters, you'll see some similarities. But really, it's our own game, and as Mrs. Hamilton said, we've been doing it for 16 years. You see behind me 28 wonderful students. There's a total of 30 of them, but you know that not all of them are going to be wonderful. Yeah, you know which ones. You know what we're talking about. Cole, I'm watching you. I'm watching you. We're going to play a game, though. We can't have all 30 of them going at once. So we're going to bring them up here in groups of 3, and they're going to face off against each other in a game of speed and reflexes, and that's very important. What they've learned today doesn't really have a lot to do with being able to push the button first. Pushing the button first is going to make this more of a game show than an educational example of their brilliance. We all know that the kids are terrific and that they know the material. Some of them are going to be a little bit faster than others in this game, and that's what it's all about. We're going to play in a series of rounds. 3 at a time, they'll come up on each team. 3 will play against 3 for 3 questions. Everything's in 3s. They'll get 10 points for every question they get right. Pat and Vanna back here are going to keep score for us. And if they get if one team gets all 3 of their questions right in that set, we're going to give them a 10-point bonus. So they can get a total of 40 points in any given set. That doesn't happen a lot, but sometimes you've got a really fast person or a couple kids on one side who will do that for us. And we'll ask you guys to sort of keep track of that. As I'm reading the questions, sometimes I forget. So David and Anna will keep an eye on things. Actually, David is going to keep an eye on Anna. Anna cheats, so you know. After we do that, after we do that, the next set of students will come up, and then the next set, and the next set, and we'll go around and around and around, and as I said, everything's in threes. They'll all have a chance to come up and play 3 times. After we've done that, we'll have established a score, and then we play what we call our lightning round. We'll get to that a little bit later when we actually get to that point of the game. I'll explain the lightning round to you then, but everybody's going to get a chance to answer one more question in the lightning round. And after we do that, after we play the lightning round, then one team will be our winners, and the winners get punch and cookies, and the losers get nothing.
Not true.
That was fun. Quentin said I should use that joke. I wasn't sure. All right, so that's what we're going to do. I don't have a podium, so I'm going to be wandering back and forth. I might be in your way for a question or two, but I promise I won't stay there long. I'll be moving around so that you won't always be looking around, have to look behind me. But we definitely want you to be focusing on our students. Once more, give it up for the marvelous mathematicians. Not only alliterative, but color coordinated. And they tried over here, there's sort of a late memo to get to wear red. About half of them got it, but Fibonacci's factory of factor fans. Students who are used to getting F's. You get that at all, but whatever. Okay. Are you guys ready to play?
Yeah!
Are you guys ready to play?
Yeah!
Oh my goodness. Let's have our first 6 players. Let's applaud for our first 6 players as they come up and take their position. The players have calculators. They also have pencil and paper. Most importantly, they have their brains. We're going to ask some questions that could be about anything. Sometimes we'll ask them to explain something. Sometimes they'll be solving mathematical issues. Sometimes they'll be able to do it in the head. Sometimes they'll need their pencil and paper. They're welcome to use whatever they need to use. The object is to hit that button first. Players, are you ready? Here we go with the question 1. If the coordinates for a point on a graph are both negative, which quadrant is the point in? And that's way over here.
The third quadrant.
The third quadrant is right. 10 points for that. Next. Oh. If we do that, we'll be here till 2 in the afternoon. And did I mention there's cookies? I was expecting more people to applaud. Everybody always applauds the first question. You were the only one. Second question, players. What is the value of 3 to the third power? Over here.
9.
Now I'm sorry, that's wrong. We'll clear that. When one team is wrong, the other team gets a chance to answer. What's 3 to the third power? 27. You just squared it is all you did. That's what okay. And final question for this set. What number begins and ends the horizontal rows of Pascal's triangle? 1 is the right answer. So 10 more points for Fibonacci's factory of factor fans. I'll be abbreviating that before we're done. 10 points for the marvelous mathematicians. This is my favorite part. Players, rotate. Yeah, sure. We practiced that.
Pretty smooth.
Absolutely. Players, new set of players, new set of questions. Question 1. Find half of 74.
37.
37 is the right answer. Next question. According to the Tartaglia sequence, 4 plus 5 plus 6 equals what?
7 plus 8.
7 plus 8 is the right answer. Show of hands? I didn't think so. Final question for this set. There won't be a sweep. Wait a second, there could be a sweep. In Fibonacci's sequence, what are the next 3 numbers? I'm going to give you 4 numbers. You give me the next 3 numbers. 1, 1, 2, 3.
5, 8.
And
13.
There you go. I did all three of them. You got it. That is a sweep, isn't it? David, was that three?
That was a sweep.
Sweep for the mathematicians. Let's rotate.
I have to defend Anna. Did you just see what she did?
She cheated?
For David.
Oh, good.
She helped him out.
Thanks, Anna.
So you gave the team the extra point?
Got the extra
And the mathematicians now have a 30-point lead. We have 6 new players.
That's our Anna.
That's our Anna. Players, here's your first question. What is the exponent form of 8 times 8 times 8 times 8?
8. 4.
How many times did I say 8? That's right. It was 8 to the 4th. You got it. That's exactly right. Clear that. Thank you, Mrs. Chase. Name a 3-digit palindromic number with a digit sum of 6. Say that really, really loud for me. 606. Remember, I said you had to be really, really loud. But unfortunately, that's not the right answer. So I have to clear that. Red team, name a 3-digit palindromic number with a digit sum of 6. 141 is one of them because 1 and 4 and 1 will all add up to 6. If you have a couple of 6s, it adds up to 12, unfortunately. That's too bad. And final question for this set. How many Fibonacci numbers are there? Infinite. It's okay. She didn't hear you. She had the right answer. An infinite number of Fibonacci numbers. That's good for another 10. Was that 3? They swept again. Mathematicians taking a pretty big lead here. Let's rotate. Players, welcome. New set of players. I've got 3 numbers that I'm going to read to you. I need you to tell me what number comes next in the pattern. 48, 44, 40. 36 is right. Be careful. Make sure it's just you, the one who's got the light on. This is a little tricky, players. Listen carefully. What 2 consecutive numbers have 2 in the tens place and have a sum of 49? 24 and 25. Good job. Final question. What is 2 to the 6th power? Remember, you have tools. What is 2 to the 6th power? You're doing it in your heads too, aren't you? We'll give them all some time because nobody's buzzed in yet, so. 64 is the right one. You got there. Good job. That's 2 for the Factor fans. That puts you back in the game here. What do you go to now? 40. All right. 100 to 40. Let's rotate. New players, here's your first question. Find half of 230. 115 is right. Next question. Name a 4-digit palindrome whose digit sum is 10. A 4-digit 5005. See, the zeros are the easiest to me. That's the way I would do it. Absolutely. 5005. Final question. What 3 consecutive numbers add up to 24? No, I'm sorry, that's wrong. I'll clear that. Mathematicians, you've got a little more time. What 3 consecutive numbers add up to 24?
7, 8, 9.
7, 8, 9 add up to 24. That's right. Good job, Cole. That's 10 more points for the mathematicians. And let's rotate. By the way, these are actual game show themes that are being played in the background. Some of you who are older, and anymore, I'm about the oldest one here sometimes, might remember some of those. I'll tell you what they were later. But there's a lot of them. Some of you recognize, some of you probably don't. Hey, I recognize you guys. Welcome back. We have rotated through one whole flight of players. When we do that 2 more times, we'll be to the lightning round. So welcome back to our first set of players. Let's get going again. Interesting question. Thinking caps. Here you go, players. What was our last palindromic year?
2002.
2002. Didn't even waste any time figuring that out. Nicely done. Find the next 2 numbers in this sequence, and I'm going to give you 5 numbers. You're going to give me the next 2 in the sequence. 2, 4, 8, 16, 32.
64, 128.
64 and 128. Those were powers of 2 we were doubling. That's right. Final question, players. What is the 5th odd whole number?
9.
9 is the right answer. Prevented the sweep. Good job. 10 points more for the mathematicians, but the Factor fans closed the gap a little bit with 2 correct answers. Let's rotate. Players, welcome back. I've got 4 numbers in a sequence. You're going to tell me the 5th number. Ready? 1, 4, 9, 16.
22.
Not 22. No, I'm sorry. So Fibonacci's fans, you've got a chance here. 1, 4, 9, 16. Give you about, not 21, 25. These were squares of numbers. 1, and then 2 squared is 4, and then 3 squared is 9, and 4 squared is 16, and 5 squared, the one I wanted, is 25. So nobody scores on that one. There won't be a sweep this time. What consecutive numbers add up to 15?
8 and 7.
8 and 7 do. So do 4 and 5 and 6, and so do 1 and 2 and 3 and 4 and 5. So there were lots of possibilities there. Final question this set. What is 300 times 9? No, I'm sorry, that's not right. I cleared that.
2,700.
2,700. You added a 0, unfortunately, and that's 10 more points for the mathematicians. And let's rotate. I hope you'll notice, though, even in a wrong answer, you can tell that they're using the processes of math correctly. All she did was add a 0. She was definitely doing the right thing in her head, but when you're doing it in your head, sometimes a little tiny mistake can make a big difference. Players, welcome back. What is the sum of the first 4 even counting numbers? That's a lot to digest. What is the sum of the first 4 even counting numbers? Ten is not the right answer. I'm sorry.
20.
It's 20. 20. 2 plus 4 plus 6 plus 8. That's right. Yeah. Players, name the next 2 numbers. You've got to give me the next 2 numbers in the Fibonacci sequence here. 8, 13, 21. The next 2 after that.
34.
And no, I'm sorry. I tried to make it clear. I was looking for 2 more, and you weren't ready for the second one. What? 8, 13, 21. Give me the next 2. There's your buzzer. Go ahead, you can. Okay. 8, 13, 21. Go ahead.
4.
That's right, 34 and 55. Excellent. Very good. Very good. Final question here. Give two different equations whose consecutive sums equal 9. Two different ones.
4, 5, and 2. 1, 2.
No, I'm sorry, that's wrong. Too bad. Two equations whose consecutive sums equal 9. Can you figure it out? Nope, anybody? About 10 more seconds here. Because you're trailing, I kind of want to see you a little closer here. Anything? Okay, go ahead.
1, 2, 3.
Nope, that's what Gabe said by mistake, and he figured it out before I showed him the right answer afterwards. 2, 3, 4. 2, 3, 4 adds up to 9, and so does 4 plus 5. So nobody scores on that one. That was 3, wasn't it? That was 3. Let's rotate. Anybody? Anybody? That's a hard one. No? No? Tic-tac-toe. Link Martindale in the 1970s. Yeah. Yeah, that was, yeah. See, I'm old. I'm old. Well, hello. Welcome back, players. I'm going to ask you to name the smallest 4-digit palindromic number. 1001. You didn't have to think hard about that, did you? Very good. What is the next number in this series? And I'm going to give you 3 numbers, and you're going to give me the next number in the series. Quintillion, sextillion, septillion, in the middle. Octillion is right. And now I'm going to ask you to give me the next 2 numbers in this sequence. I'm going to give you 4, you're going to give me the next 2. 35, 50, 65, 80, 35, 50, 65, 80, the next 2 numbers from you. Over here.
95, 110.
What? Nicely done. 95, 110. We were adding 15 each time. Good job. That's 3. Let's rotate it. Oh, Cole and Quentin are back. We're going to keep an eye on Cole and Quentin. When they, yes, I'm a little worried about them. When they come back around the 3rd time, we will have gone through our whole sequence here. This is the last round. This is the last group in the 2nd set. Players, welcome back. In Tartaglia's sequence, what is the answer to 9 plus 10 plus 11 plus 12?
13 plus 14 plus 15.
That's exactly right. 10 points for the Vector fans. What is the next number in this sequence? And I'm going to give you 5 numbers. Listen carefully. This is tricky. I'm going to give you 5 numbers. You give me the next number in this sequence. 4, 6, 5, 7, 6.
Okay.
Say something.
8.
8 is right. Good job. Yeah, that was tricky. We were adding 2, subtracting 1. That was very tricky. Final question. What is half of 850?
425.
Right for a sweep. Good job. That's getting back at the game. Let's rotate. No idea, do you? The original College Bowl. If it wasn't for College Bowl, and there wouldn't be shows like Quizbusters. Players, tricky question to get you started with your last time up front with us like this. What two consecutive numbers have a 1 in the hundreds place and have a sum of 265?
132 and 133.
If you were louder, everybody would have heard you say the right answer, 132 and 133. That's exactly right. Good job, Trent. Next up, what would the last two digits need to be to make this number a palindrome? 53,635. 5-3, it's got to be 3-5 at the other end. And the final question for this set. What is 8,000 times 600? What is 8,000 times 600?
4,800.
No, I don't think you got it. I'm sorry, I'm going to clear that. What is 8,000 times 600? Trent.
4,800,000.
4,800,000. Way up there. Absolutely. Good job, Trent. 10 more for the Factor fans. They've narrowed the gap even further. Let's rotate.
It's the Wizard of Oz. The odds are that you'll be a winner today. Wizard of Oz. The wizard is here to make you feel okay.
Who's old enough to remember the show Family, not Family Ties, Growing Pains, remember Growing Pains? That was Adam Thicke singing. Nah. You kids have no idea who I'm talking about. Oh, very good, Ed. I like that. Very nice. All right, players, let's get going. Another 3 questions here. What is 57 plus 25?
82.
82 is the right answer. Do some math in your head. That's exactly right. Yeah, he's fast, isn't he? Next question. How many zeros are needed to write the number 1 billion?
9.
9 is the right answer. By the way, 9 is the right answer in this country. In England, it's something different. That's true. That's true. Name a 3-digit palindrome. Excuse me, I say that again, but it's the same thing. Name a 3-digit palindromic number with a digit sum of 10.
505.
505. Those zeros pay off, don't they? 505. That's exactly right. 10 more points for you. And let's rotate. Is that a sweep? Is that a sweep? All right, very good. That's what I had to tell you. For reasons that are far too detailed to get into, I'm sort of editing on the fly as we go through some of these questions. So that's why you see me taking one, doing that, and putting them aside. We're getting closer, aren't we? All right, players, new set. Here we go. What is 400 times 60? 400 times 60. 24,000 is the right answer. Good job. You know what I like? They've got calculators. Nobody's touching the calculators. It's a point of pride not to use the calculators. Next question, players. Double the number 99. 198 is the right answer. I'll be loud for you. How does that sound? Yes, that's the right answer. Good job, Clara. Final question. What is 68 plus 35? 68 plus 35. Oh, good. Is somebody quiet again? 103 is right. 103 is right. Trust me, she said it. 10 more points for the Factor fans. Let's rotate. players, welcome back. Here we go. In which quadrant would you find -3, -6? The third quadrant. That's where all those negative numbers go, right? Isn't it? Next question. What is 500 times 90? 500 times 90. 45,000 is right. 10 more for the Factor fans. Finally, what is a 4-digit palindrome that has a digit sum of 6? 3003. Sweep for the Factor fans. That's right. 10 more points. 10 more points. Add some 10 points for that. And let's rotate one more time. 3003. I think I might have been given some hints now. I told them to play that 0 thing. 1221, 2112. All of those are palindromes that add up to 6. Tricky question, players. Our last 3 for this round, but remember we've got more to play. We'll explain to the parents this is what we'll play in a second here. But boy, we're close now. Players, what number am I? Pay attention to this. I am 14 less than half of 500.
236.
236 is right. Well done. I've got 3 numbers. You tell me what the next number is in the pattern. I've got 3. You tell me the next number. -30, -20, -10. 0 is the right answer. Said more than one person there, but that's okay. We did Fibonacci? Did we do Fibonacci? Okay. Just making sure, because it's the first time I've seen one. Okay, I want to make sure. In the Fibonacci sequence, what comes after 7, 13, 24?
44.
44 is right. 10 point bonus. Factor fans have taken the lead. Well done. What a comeback, huh? So we're going to have a game. I'm going to ask these 6 players now to go back to the back where you were before. Everybody stay put here while I explain some things to the parents. It's now time for the lightning round. Different questions for the lightning round. We're going to have every single student come up here and one at a time answer one more question. We'd like to think possibly a little bit easier question, but the pressure's a lot greater because they're right up here and they're looking at you and there's a camera. Kaylee's got a camera in their face. It's awful. They'll score 10 points for every correct answer. We'll start with the team that's trailing. They'll set a score that the team that has the lead currently will then have to beat. With that furious comeback, our Factor fans have a 10-point lead in the game. So mathematicians, you've got to come up here and set a score that they'll try to beat later. So Tanish, bring us right on over here. Give them a hand as they come this way. No. Which way is it? Yeah, exactly. And I need to tell Kaylee, Kaylee's getting our whole run of everybody, but in a second here she's going to turn back around here on us. And I'm going to remind her that I'm not important, you're important. You ready to do this? Yes. 10 points each. Players, pay attention. We're going to move pretty quickly. That's why we call it the lightning round. Fast, 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 fast. Here we go. 5 times 3 plus 10 equals what?
25.
25 is right. Come on over here. Next. What is the square root of 100? 10 is right. Come on around here. The numbers 9, 18, 27, 36, and 45 are all multiples of what number?
9.
9 is right. Come on, move along here. Sullivan, what is 600 times 40?
2,400.
No, you missed a 0 again. It's 24,002. That is a tricky thing to do. Don't worry about it. You just worry about your 10 points, okay? All right, very good. If you wrote the Google number, how many zeros would you write? 100 zeros is right. That's a Google. Bella, what is the digit sum of 4,522? The digit sum of 4,522. 13 is right. Very good. Come on over there. What do you use around two numbers to show a coordinate pair? Parentheses is the right answer. Closer. You didn't see that, did you? No, good, good. Because you know Anna. Worry about Anna, but okay. Here's your question. How much is 8 times 6 times 4 times 2 times 0? Eight times 6 times 4 times 2 times 0. Have any idea? Gabe will tell you. It's 0. Because it was times 0. Once it's times 0, the whole thing's 0. Yeah, that was a trick. It was a trick question. It was a horrible thing to do to this young lady. I'm sorry. Come on back and take a seat. Gabe's over here grinning. I've got it, I've got it, I've got it. So I'll have to give you a hard one, right? All right. What two consecutive numbers add up to 23? What two consecutive numbers add up to 23?
11 and 12.
11 and 12 add up to 23. That's right. Fill in the missing number in this sequence. 15, 18, blank, 24, 27. 15, 18, blank, 24, 27. Fifteen, 18, blank, 24, 27.
Oh.
21 is right. Yes, there were three. There were multiples of 3. Good job. Ready? This is hard, but I bet you can double the number 66. You are very good at this. That's exactly right. Good job. Take your 10 points and go on back. Aiden, 3 times 2 times 5 equals what? 3 times 2? 30 is the right answer. In his head, he's doing this. Grace, next number of the sequence. I've got 3 numbers here. Million, billion, trillion, quadrillion is right. Angie. No, all the way around, even further, because I want people to see this butterfly. I love that butterfly. All right, very good. Angie, what two consecutive numbers give a sum of 17? I will. What two consecutive numbers give a sum of 17? Eight and 9 is the right answer. Cole, you ready? Tough one. Anna can handle it. You ready? Double 89. You're good at this. Very good. All right. Good job, Cole. Give the mathematicians a hand. So 370 for the mathematicians, 250 for the Factor fans. The mathematicians are our winners. Let's eat. No, that's not how it works. Trent, get over here. Come on. They did good, didn't they? Put a lot of points up there. It's 12 to tie, 13 to win, and 15 chances to do it. That's not bad, but it was a close game, so it's going to come down to this. You ready? We have to wait for Kaylee. She's showing off. When you watch this on the video, you'll say, oh, she's very good at this. All right. Trent, which of these is greater? 2 to the third power or 3 to the second power?
They're equal.
No, they're not. 3 to the second power is 9. 2 to the third power is 8. This is tricky. This is tricky. Name a 4-digit palindrome that you could find on a digital clock. No, not 1212, you'd have to go backwards. 1212, 1221 would have been one. 1001 or 1111. Oh, I got to get some of these here. What two consecutive numbers add up to 11? 5 and 6 is right. What is half of 230? 115 is right. Wyatt. In your head, think about this. Is 65,356 a palindromic number? 65,356.
Yes.
Yes, it is. 65356. That's right. What's the next number in this sequence? I've got 4. You'll give me the last one. 24, 30, 36, 42. She can't see the answer. 24, 30, 36, 42. Because my thumb's on the answer, and now I'll get. That's right. 48's the right answer. Good job. What is half of 2012? I know you can do this. What is half of 2012? 1006. You did that easy. You made that look easy. Clara, get over here. What is 10 to the third power? 1,000 is right. Fiona, you're next here. We did that. We did that one right. What is 5 times 800? It works either way. What's 800 times 5? Okay. Should I tell them what you said? Okay. She said 4,000. Now should I tell them whether you're right or not? Yeah. She was right. Good for 10 points. Grace. What is the consecutive sum for 5? My goodness, that was an easy one, wasn't it? It feels good to get an easy one and not have to worry about it, doesn't it? You ready? Another hard one. Double 1,234. 1,234. $1,234. Right, 2,004. That was terrific. That's a lot of pressure in there, wasn't there? Julie, come over here. What is the digit sum of 5,320? The digit 10 is right. That's right. What is 10 to the fourth power?
10,000.
10,000 is the right answer. Michael, what is the exponent form for 5 times 5 times 5 times 5?
5 to the fourth power.
5 to the fourth power is right. Quentin. Look over there.
Pleasure.
How you doing? You ready for this? What is negative 15 plus 30?
15.
15 is right. Our Factor fans are our winners by 10 points. I told him, look, I think he's just now realizing what's happened. In 16 years that we've done this, we actually had ties twice. And one time, we had a team that was behind by 10. This was heartbreaking, and we'll never forget it. A team that was behind by 10 points when the last young man came up to answer, and he missed it. Or it would have been a third tie. if Quentin had just gotten that one wrong, we'd have had another tie. But it's always been wonderfully close. You can tell these kids have really learned a lot in the last couple of weeks, as if they weren't smart kids already, you know that. It's been a joy for me to hang out with them for a little while. We're going to continue to hang out, but we've got a little bit more stuff to do here. Please welcome Mrs. Hamilton back.
Well, as Matt said, every year before this, I pray for a tie. It's really what we want. But this is terrific because obviously this was a very exciting game. Could have gone either way. And so I have to give you my favorite quote, and I think this is a great life philosophy. I have never lost. I have only been behind when time ran out. And I think that's true here today, so give them another big round of applause. I need to thank some very important people, and I thank Matt Ottinger for introducing me, because I always forget to introduce myself, but I am Deb Hamilton, and you probably see my name on letters that come home to you. I coordinate gifted and talented programs here in Okemos. And it is a joy for me not only to have the benefit of your wonderful students, but also to work with colleagues that are really true joys in their energy, their enthusiasm, their knowledge, their love of teaching and learning and working with children. So it's a delightful opportunity for me. So I would like to start out with, once again, thanking our wonderful game show host, Matt Ottinger, because I just don't know how we'd make this work without him, guys. I can't do it. So please give a big round of applause. And then I would like to introduce some very, very important people who you may or may not have met yet. The first of which is Mrs. Eugenia Poltalaika, who is one of our Math Academy teachers and has been with us for many years, and we hope she keeps coming back. So keep coming back, please. And our other Math Academy teacher, who again has also been with us for multiple years, and it really is so wonderful when staff like Eugenia and Ingrid keep coming back, because the continuity and the flow of the curriculum and just their wonderful expertise and experience is really wonderful. So I would like to also thank Mrs. Ingrid Yarbrough. And finally, really a person that we couldn't do without, who is here on site every day, making sure that any issues that arise or any equipment needs or any supplies or just anything in general needs to be dealt with, and also is very instrumental in overseeing curriculum, in helping us to make sure that children are here and are able to participate in these kinds of programs. My wonderful colleague, who is the Gifted Education Consultant here in Okemos, Marcia Chance. So I'm going to turn it over to Marcia now, who has some special award certificates to acknowledge your children's participation. And again, thank you very much for your support.
Thank you again for bringing your kids here every day. I know it's early in the morning, even earlier than the regular school day, so I appreciate that very much. It was a pleasure to work with them. I wanted, before I have the kids come up and give them their certificates, I wanted to thank again the student assistants, because I'm the one who kind of bosses them around, so I felt like I needed to personally thank them. And I thought one of the best ways to do it was to read a comment that one of the students made. We had all the students fill out evaluation forms, just like we asked the parents to do. And this was one of our students' comments that he made. Math Academy is a great experience for me. I like how Mrs. Y and Mrs. P teach. And thank you, Mr. David and Miss Anna, for being great para-pros in the classes. You got upgraded. But I thought that they were, comparing me to the caliber of a paraprofessional was really something you needed to hear. I have certificates for all of the students, and we're going to start with the marvelous mathematicians. So Tanisha, if you would lead your class up and get in line just like we're doing lightning round. The teachers, if you would join us. This certificate is presented in recognition of successful participation in the Okemos Math Academy for June 27th, 2013. And our first certificate goes to Tanish Devereaux. Congratulations. Zara Hertefeld. Zara, come this way. Shake the hand. Fernanda Gannon. Congratulations. Sullivan Plus. Valia Kulkarni. Bella Lyon Callow. Rashika Mukherjee. Shika Nukala. Probably said that wrong. Dave Perkins. Shreya Ravapati. Annika Saffron. Aiden Song. Grace Sight. Ann Jiju. Zimmer. Thank you. All right, Trent. Bring yours as well, please. Good to not East Factory of Factor fans. Yeah, you can swing around this way so you're a little more comfortable. Okay, first certificate goes to Trent Amundson. Congratulations, Trent. Aryan Bonula. Ozan Pollock. Hibah Fatteh. Wyatt Jersey. Congratulations, Wyatt. Audrey Walton. Congratulations, Audrey. Shreya Kathareddy. Claire Lau. Fiona Magyar. Grace Nixon. Nadav Herparat. Okay. Julia Scarpetta. Pranav Srinivas. Michael Wang. Quentin Zeller. Thank you. There is punch and cookies for everyone in the back. Help yourself.
And we put Kaylee to work. We might make that worthwhile with these nice people.
Thank you.
We did obviously record today's little event, and we want all of you to have, as in not pay for, a copy. We've got a sign-up sheet over here on the where the folders are. Please put your name and your address, and we'll turn this into a DVD and we'll send them to you. Okay? Thank you very much. Let's eat. Let's eat. Oh, wait, don't eat yet. Don't eat yet.
All of your students' work is over here on these tables. They should all have 2 folders. I will actually put them in the middle of one door. We always have several left. So if you could help your student remember to take both folders. If you have not had an opportunity to do an evaluation and like to turn one in, I put a few extras over here. Okay?
And I'd also like to thank Patricia Trustad, who is our deputy superintendent, for being here. She's always so supportive.
Good job, Clara.
I answered the question.
Hey, good job. High five. Yeah.
Good job, Lady.